Alright, today we're going to do some stuff with systems of linear equations. Up till now, every system of linear equations we've got had an answer. The answer was like 2, 3, negative 1, 5, sometimes 17/35, comma, negative 23/35, and you got mad at me, but oh well. Alright, the point is, their systems of linear equations always have this answer. And what I want you to understand is everything we've seen so far has been a consistent, independent system of equations. Okay, so a normal system of equations is going to have the characteristic of being a consistent system that's independent. Okay, that means you have exactly one solution. If I was graphing the lines, one line does that, the other line does that, they intersect at some point. That's what we've been seeing up till now. All right. Today we're going to see two different scenarios. Okay, and what's going to happen is we're going to do elimination substitution as we normally do. If after eliminating or substituting you still have a variable in your problem, 5x equals 20, 2y equals 18, something like that, it's going to be a consistent independent equation with a normal answer. If in the process of eliminating x, y goes away also, or the process of substituting x for y, and then y goes away anyway, the other variable cancels, leaving a true statement. You have a consistent equation again, system, but it's dependent, and the solution is all real numbers. Graphically, what's happening there is equation 1 creates a line, and equation 2 creates the same line. Pretend those are the same line. You're supposed to lie right on top of each other, but pretend they are. All right. That's what consistent dependent means. That means that any solution for one is a solution for the other. They're all the infinity points of intersection. All right, the third scenario, do elimination substitution as normal. In the process of eliminating x, y goes away also, or vice versa. The other variable cancels, leaving a false statement. Then you have an inconsistent system of equation. There are no solutions. What that looks like graphically, line 1's here, line 2 is parallel. They never intersect. We're looking for a point of intersection, they don't have one. All right? So that's what happens. So basically what we're going to do today is we're going to just do like normal, elimination substitution. I want to get rid of x, so do what's necessary to get rid of x. And then if everything stays as is, it's basic, consistent, independent, go ahead and finish it. Otherwise, tell me the two possibilities. So, example 1. Is the following system of equations consistent or inconsistent, dependent or independent? So, the setup here, y equals x plus 2, y equals negative 2x minus 1, is better suited for substitution than elimination. So if I take this x plus 2 that y equals and put it in place of that y down there, I get that. X plus 2 equals negative 2x minus 1. I go ahead and continue solving. I move the 2x over here. I move the 2 over there. The 2x becomes positive. The 2 becomes negative. X plus 2x makes 3x. Negative 1 minus 2 is negative 3. Notice I did substitution as normal, and x didn't disappear, right? So this is just a normal system of equations. This is consistent, independent.
So this has nothing to do with like y, so like when we're doing all these we want to find x.
Oh, I'm going to go ahead and find y also.
Oh, okay.
On the consistent independent, then I want to identify it as what it is, but now I want to go ahead and finish solving it, because again, with consistent independent, there's a solution. I want to find that solution. So if I finish this out, x equals negative 1, and y equals x plus 2, changing x to negative 1, y is equal to 1, negative 1 comma 1 is the solution. So for consistent independent specifically, I want you to go ahead and finish out the problem, do what you normally do, find x, find y, write the ordered pair.
So how does it become independent?
That's what it is. If it has an answer, a specific answer like that, so think of this as like a multiple choice test, okay? The three choices are consistent, independent, consistent, dependent, or inconsistent. Those are your three choices. All right? So if you get a normal graph, a normal equation, has a normal answer, the answer is consistent, independent. All right? That's it. So it's just, those are the three possible answers. All right? So once you see it's a normal one, x stuck around, and you're going to understand the sticking around part in just a minute when you see the other two examples, because the other two examples, x isn't going to stick around, or y, whichever one. But In the process of doing substitution, everything is as normal. X stays in the problem. X equals some number. Consistent independent is the type, and -1, 1 is the solution.